Okay, Algebra 2, this video lesson is going to be like the last one that I made for you. I'm simply going to walk you through the answers to a packet of questions that I've given you. In this case, these are harder questions. Like the last one, they are questions about factoring and solving polynomials, but this is a harder batch of those types of questions. I think I've said before more than once that factoring and solving polynomials is one of the most challenging aspects of the course every year. So I won't be surprised if these were tough questions for you, but let's go through them. The first one here, x to the fourth plus 5x squared minus 24. Well, remember, we were only given 4 rules. We should look for greatest common factors. I don't see any greatest common factors among these. Second, I should be looking to see if these are sum or difference of perfect cubes. Well, these aren't even cubes. So then the third thing is, if I have 4 terms, I can split them, but wait, I don't have 4 terms. So there's only one more option left, and that one more option that's left is to see whether or not I could factor this if I treated it as though it were like a quadratic, or as the textbook says, in quadratic form. And that does work. So instead of calling it x to the fourth plus 5x squared minus 24, and every time I get one of these situations, I'm going to draw a little asterisk for myself to remind myself that I'm entering the world of make-believe. This isn't really true, but I'm going to act or pretend that I was actually asked about a quadratic. In this case, x squared plus 5x minus 24. And the key point to realize is that I've reduced the exponent from 4 down to 2. In other words, I've chopped it in half. Now I've got a quadratic I know how to factor. I'm looking for factors of negative 24 that add up to make 8. Those are 8 and negative 3. Now I come back out of the land of pretend by changing that x in both of those cases back in the opposite direction of what I'd done before. Previously, I'd taken those exponents and cut them in half. So now I'm going to take the exponent that I have and I'm going to double it. So the exponent on the x was 1, I make it 2. So this is my answer, x squared plus 8 times x squared minus 3. Moving over to this one on the right here. In this case, I do have a difference of perfect cubes. This is that, let's see, I think it was the second of the 4 different scenarios that we've talked about. Okay, so I set up my framework, the place, the landing pad where I'm going to put my answer. And remember, it's going to be a binomial times a trinomial. Remember that the binomial sign is going to be minus sign. The operation in the binomial is going to be minus if this was minus. And these are both going to be plus. And in here and here, well, what I'm going to put is the cube root of this thing, which is 4x. And here I'm going to put the cube root of that thing, which is 5. Okay, so now I've got that much done. I've got the binomial. Now here, I'm going to put that squared. And here, I'll put that squared. So now I've got 16x squared here and 25, in other words, 5 squared here. The only thing that's left is to fill in the middle. The middle is simply that times that. 4x times 5 is 20x. And the last and key point to realize, it stays plus. Even though you're looking at 4x minus 5 and you might want to make that negative 20x, just remember, right from the beginning, I said the only minus sign that I'm going to be able to use is 1, and when I'm subtracting perfect cubes, that minus sign appears in the binomial. It's different if this had been a plus sign, but we'll talk about that in an example soon. In fact, whoops, looks like, and I didn't mean to move that, we're going to talk about this a little sooner than I'd intended. I meant to cover that up and build this. Okay, now this is a case where I've got 4 terms. So when I've got 4 terms, I talked about this with you. Well, I'm sorry. Let's hit the pause. Okay, there. Sorry about that. What I forgot to say was, even before anything else, remember the first thing I told you to look for was the greatest common factor. And after that, you can look at things like whether or not you've got sum or difference of cubes or 4 terms or other issues. Well, these do have a common factor. All of these 4 terms have 8 in common. So I can pull 8 out to the side. Now I'm left with a more reasonable set of 4 terms, smaller numbers that aren't going to be as hard to work with. Now, like I said, when you've got 4 terms, split them. Left and right sides get treated separately, and you'll find that the left side becomes, well, if you factor from the left side the x cubed out, you've got this. And on the right side here, I can factor the 8 out. So you should see that I've now got x cubed plus 8 times x plus 1. And 8 off to the side. The one thing I want you to make sure you realize, though, is this, which I've underlined here in red. This x cubed plus 8, this is what I was talking about before. This is a case where I've got a sum of 2 cubes. Well, once again, I've got to factor that thing out, and it's going to be a binomial, in this case x plus 2, times a trinomial, in case this trinomial here. So I kept the 8 that I had before, I kept the x plus 1 that I had before over to the right, but in the middle, I've got a binomial and trinomial in place of that x cubed plus 8. So how do I know now that I'm done, as opposed to any of the earlier stages? Well, I can't do anything more with x plus 2. I can't do anything more with x plus 1. And this term in the middle, well, try cross them up and split the middle if you want, but you'll find this can't be factored any farther. Remember, we're only asked to factor here. Don't try using the quadratic formula. This is as far as we can go. Now moving on to the one on the right, and again, I had intended, I'm going to hit the pause button. There, I was starting to say that I'd intended to have these answers covered up rather than throw you all of the answer at once, but to reveal it a piece at a time. All right, here's another case where I can factor out, I could have factored out the 3, couldn't I? And that was a mistake. I should have factored out the 3, and I'm realizing that I didn't. So let's make sure that we end up with the right answer. But I've split the left and the right. So on the left, I've got 3x cubed times x plus 2, and on the right, I've got minus 24 times x plus 2. So now I've got 3x cubed minus 24 times x plus 2. And notice that on the left, well, I ended up doing it later. I factored the 3 out. So it's all going to work out. The answer to the question I raised is yes, I'm going to give you the right answer. It's just I could have factored that 3 out from the very beginning, but I have it here now. I've got 3, and I've got x cubed minus 8, and I've got x plus 2. Remember, this binomial here, this is a difference of perfect cubes, so I can go farther. And the answer that you should end up with is this one here. And I know at this point that I can't go any farther than this. I know I can't do anything more with x minus 2 or x plus 2. And this middle term here, this trinomial, you can try cross them up and split the middle if you want. You'll find this can't be factored farther. So this is the finished answer for this question up here. Moving on now to this question. All right, this is another case of something that's like a quadratic. There are no common factors here. There's nothing for me to pull out. So I'm going to treat it like it's 8x squared minus 18x minus 5. And in that case, I got to use cross them up to try to factor it further. 8 times negative 5 is negative 40. Put the negative 18 at the bottom. And you'll find that 2 and negative 20 multiply to make negative 40, add to make negative 18. So I'm going to have 8x squared plus 2x on the left. And on the right, I'm going to have negative 20x right here minus 5. Okay, so that left side, I can pull out 2x. On the right side, I can pull out negative 5, and that's what I've done. Now I put the 2x and the negative 5 together. I've got 2x minus 5 times 4x plus 1. But all of this, all of these steps are simply what I taught you back in December from chapter 5. What you were actually asked, don't lose track, was not about 8x squared. You were asked about 8x to the 4th. That's why I make all these asterisks for myself, to remind myself I'm actually operating in make-believe. Now I'm going to bring this back to reality. It shouldn't be 2x. What I did before was chop the exponent in half. I need to double that exponent. I've got 2x squared minus 5, 4x squared plus 1. The reason I know I'm done at this point is because I don't have any rules that help me go farther in factoring a quadratic like this that's not a difference of perfect squares. I certainly don't have one that's for a sum of perfect squares. So that's it. That's the final answer. Let's move on now to this one over here. In this case, I can pull out greatest common factors. In this case, the only common factor is the x cubed. So I pull that off to the left. Now on the right I have this trinomial. It's quadratic-like. There's nothing else that I could do with it. So let's see what would happen if I called it 2x squared and minus 11x plus 56. In that case, I'd put 56 at the top, minus 11 at the bottom. You're going to find that can't be factored. And when that happens, you're done. So the answer in this case, and this is the only case on either the front or the back where this is true, you're very quickly done. And this which I had at the very beginning is the right answer in the end. Now I apologize, I can see this is going to be a long video. It looks like I'm probably going to have a full video on factoring and a full video on solving. I'll keep going here with the factoring side of the page. Here I've got another set of four terms, and they don't have any common factor. So I split the left and the right. You should have that. Now I've got 9x squared minus 4 on the left. Well, wait a minute. That is a difference of perfect squares. So don't stop there. Keep going. Make it 3x minus 2, 3x plus 2 times x plus 2. That's your final answer. That's the fully factored form of the expression I was originally given. This one in the upper right here now. Well, notice that this is actually a perfect square, and this is like a perfect square. It's quadratic-like. There's nothing else that I can do with this. It's not difference of cubes. There's no greatest common factor. So I treat it like it's 1 minus 4x squared. That would have made it 1 minus 2x times 1 plus 2x. What I had done was I had chopped the exponent in half, so let's double that exponent. It becomes that, and now I'm done. Moving on to this one. Now we're dealing with to the 8th power. Well, I don't have anything else in my bag of tricks to do with this except treat it like it's a quadratic. If it had been a quadratic, well, I'm sorry, I could pull the 2 out, couldn't I? I pull the 2 out. Now I don't have anything inside the parens that I can do with that other than to treat it like it's 2x squared minus 9. I highlight this with an exclamation point and circle this in red to remind you this time I'm reducing the exponent by dividing it by 4. So don't lose track of what you're doing. But x squared minus 9 is an easy difference of perfect squares to factor. That would be x minus 3x plus 3. So all that I have to do to bring this back from make-believe to reality is remind myself I divided by 4 that time. So raise the exponent by 4. And that's the finished answer. 2, well, I won't read it out loud to you. You can see what it is. Over here, and I believe this is the last of the factoring questions. The only thing that I can see to do right away is to pull out the greatest common factor, which is negative 1. Now, in the parens, I've got something that's quadratic-like. I'm going to look at how I would factor it if it had been a quadratic. Then it would be x plus 3x plus 7. So I'm going to raise those exponents back to reality and make it x squared plus 3x squared plus 7, not losing track of the negative 1 that I'd factored out at the beginning, and now I'm done. Okay, that's all there is for the factoring side of the page. I'm going to have to make a separate video, it looks like, about the solving side of the page.